Hello and welcome back to the course on artificial intelligence. All right, so I hope you're enjoying the tutorial so far. We're nearly done with the intuition. You'll very soon get to the practical side of things. We've just got a few little things that we need to cover off. All right, so previously we talked about how we add neural networks into this whole equation of Q-learning and take Q-learning to the next step and turn it into deep Q-learning. And today we're going to add an extra important feature which you will be coding in the practical side of things. So Hadelin and I decided that it's important for us to cover it off in the intuition side of things so that you're more prepared for it when it comes in the coding side of things. So as we discussed, we've got the network there. There's two parts that happen. First of all, it's the learning. So the network actually learns with every new state. It slowly updates its weights to get better and better and better at dealing with this environment. And then there is the acting inside the state. So after the Q values have been counted in the state, then one Q value is selected. So today we're still going to talk about the learning part. We're going to come up with a interesting feature that's going to, well, we're not going to come up with this feature ourselves, but we'll talk about a feature that is very important for deep Q learning, and that feature is called experience replay. All right, so here is our network. So we've just copied it over here. We've got that loss that is calculated at the bottom is backpropagated through the network. And let's have a look at an example of what happens to understand the problem that we're dealing with a bit better. So here is an example actually from this course. This is a screenshot exactly from this course. This is what you'll be programming. This is a self-driving car that is driving through this along this road, and it has to learn how to navigate this road. And so what is, as we discussed previously, what is this in this state? And of course, the state is not just going to be x1 and x2. Adlan will describe a bit in a lot more detail what the state is. It is going to be a couple of parameters which relate to the angle of the car and some relative parameters, what the sensors are reading, and so on. So there's going to be more parameters than that to describe the state, but nevertheless, it's going to be a vector of values. It's going to go through a neural network, and then on the output, you're going to have some Q values. Again, there will be a different, depending on this environment, there can be a different number of actions, possible actions, but we're just going to, for simplicity's sake, leave it at 4, just for us to be able to understand a bit better what's going on here. So in this case, the question is so far, what is this input into this neural network? Or more specifically, how often do we trigger this neural network? How often does this neural network go through? Well, every time the car ends up in a new state. So the car makes a move, it ends up in a new state, and then all that data, all that information from about the state goes through the network. Q values are calculated. This error is calculated based on what we discussed in previous tutorials. This error is backpropagated through the network, weights are updated, then the car selects which action it wants to take, makes that move, ends up in a new state. In the new state, everything starts over again. And so basically this happens every time the car is in a new state. Well, have a look at this example. I specifically took this screenshot because it's very well illustrates the problem that is addressed through experience replay. And experience replay is not just something that we use in this course or in this specific problem. It is something that you will see used throughout, like on and over again in artificial intelligence algorithms, because it is so powerful and it's so important. So look at this car. This car in this problem or in this environment, its goal is to go from here to here and back. Its goal is to navigate its way here without crossing these walls which are made of sand. And so the car started over here, it went down, and like its reward is based on how close it is to its target. So the car went from here, it went down, and kept going like this, along this wall. And what it's going to do next is going to turn, and it's going to keep going. Well, what we want it to do is keep going here. But let's think about it for a second. Once it got to this wall, every single time it moves forward, and so on, it moves forward. So there might be, like, depending on the structure environment, it could be like 100 moves here or 50 moves here. It just keeps moving forward. And nothing changes. nothing really changes. Yes, it gets further away from this target, closer to this target. That's lovely. But in terms of the surrounding environment, not many things are changing. It's still that same wall. If you're sitting in the car, you've probably seen this situation when you're driving, and the whatever you're seeing is like the environment is so monotonous that you're just seeing kind of the same thing. It's just passing by. But imagine you're driving through a desert and you're just seeing the same thing. It's the same sand. It's the same sand. Nothing is happening. Nothing is changing. And so but every single time we're putting that new state into here. Yes, of course, something might be changing. For instance, you're driving the car and your GPS is showing you're closer to your destination. So one of these inputs is changing. But a lot of these other inputs, the sensors, for instance, which are on the car, they're not changing. And therefore, as you're driving, so in this state, you input the inputs into your neural network here, and here. All the time, the inputs are pretty much the same. And so if you keep inputting the same inputs, the same values, the same vector, or very similar vectors into your network, because there is no variety, the car will learn very well one thing. It'll learn very well how to drive along this wall, which is on its right. And so that's how the network will update, and it will get rewarded. It will slowly start getting rewarded for driving so well. It will be like, oh, okay, so from here it'll start learning. Oh, I'm doing so good. I'm doing even better. It will have this false perception that it's actually doing very well, even though it only learned how to drive along this wall. And so the neural network will become very adapted to driving along this wall, and then all of a sudden there's this curve and the car doesn't know what to do. And it completely doesn't fit in with this neural network. And even if it does adjust somehow, let's hypothetically say it passes this part and then it ends up on this wall, same thing is going to happen. It's going to drive from here. Okay, now the neural network is restructuring itself to adapt to this wall. And then bam, this thing happens. And then even if somehow it gets past that, it'll drive past this thing. And then same thing along these lines. So basically, it's like a very vivid example of a problem that we have is that because the way we're using the neural network, updating it with every single state, once we have lots of consecutive states, they don't even have to be the same, but there is in environments, it's normal that consecutive states are somehow correlated or somehow interdependent. And we don't want that interdependency to bias our network. We don't want the car to just learn how to drive along like a straight line or along a curved line or like anything that you think that you can think of in life where an agent would be navigating an environment, wherever you can think of correlated or interdependent states that come after another, that can really mess up your neural network if you're just going to let the agent learn from that. And that's where experience replay comes in. What happens in experience replay is these experiences, so these states that it's in, 1, 2, 3, however many, 50 states here in a row, they don't get put through the network right away. They're actually saved into memory of the agent. And so, for instance, it saves all these, and at some point, once it reaches a certain threshold, which you'll be able to code, and Adlan will show you how to do that, once it reaches a certain threshold, then the agent decides for itself, okay, it's time to learn. I have this batch of experiences that I have, and now I'm going to learn from that batch. And so it randomly selects a uniformly distributed, and uniformly is important here because that's something we'll talk about on the next slide. We'll mention that, but it takes a uniformly distributed sample. So basically all experiences are considered to be equal. It takes a uniformly distributed sample from that batch of experiences that it has, and then it goes through them and it learns from them. So it doesn't take all the experiences, it just takes a uniformly distributed sample. So it might take a couple from here, a couple from here, a couple from here, and each experience is characterized by the state it was in, the action that it took, the state it ended up in, and the reward it achieved through that action in that specific state. So 4 elements in each experience: state 1, action; state 2, and reward. And so it takes all those experiences and then it passes them through the network and it learns. And that way it breaks the pattern of that bias which comes from the sequential nature of the experiences if you were to put them through the network one after the other. So that's the main focus of experience replay. That's what the problem it addresses. And another benefit of experience replay is that sometimes in an environment like this, you might have very valuable, rare experiences. So, for instance, I don't know. Let's look at this corner, right? This is a right corner, right, and a very sharp one. How many sharp? So it'll be coming from here, assuming it's going to be hugging this corner. So how many sharp right corners do we have in this whole environment? We only have one right corner here and one right corner here, right? So when it's coming this way, that's a right corner. And then when it's going back, it's a sharp right corner here. So, and this one's not sharp, this one is sharp. So there's only one opportunity in the whole environment to learn from a sharp right corner. And that's an important experience, because it might get really good at driving along straight lines, get really good at doing like soft corners like that, and then it will keep messing up this sharp right corner simply because it doesn't have that much opportunity to learn from it, and so therefore it will learn everything else pretty quickly, but it'll take a long time to learn this right corner. It's a very simplified example. It's a very simplified explanation, but it illustrates the concept that sometimes there are rare experiences which can be valuable. And if you're just doing a simple neural network where you're putting in your values here and they're going through, and like even if we forget about that problem of the sequential nature of experiences and how they can be interdependent or correlated, even if we forget about that for a second, what happens is once you put an experience in, it goes through, the network's updated, then you instantly forget about that experience, and you move on to the next one. That's just how the neural network works. Then you move on to the next state, the next state, the next state, the next experience, next experience, next experience, and so on. So this right corner, as soon as it goes through the network, it's gone, and you don't have any memory of that valuable experience. Whereas with experience replay, because you're putting these experiences into batches, you can organize your batch as a rolling window. So for instance, you could have like 100 batches, so 100 experiences in your batch. So when it's coming back from here, it's as soon as it has this recorded this experience in its batch, then like at some point it takes a uniform distribution from its batch of experiences, and then there's a rolling window. So it forgets these experiences, but then it keeps these experiences. And then again, it learns from, once it's here, it learns from this batch. And then once it's here, it forgets all the way up to here, but then it has a batch of experiences like that. So therefore, now it learns from these experiences. And that way, what you're getting is that this right-hand corner, it might come up several times in its learning process because it was in that batch when the batch was like this, around there, then it was in the batch here, in the batch here. So it came up in several batches because a batch might be updated as a rolling window of experiences. So the older experiences get kicked out, the newer experiences are added, and then again, older experiences get kicked out. So an experience it stays in the batch for quite some time, and the car or agent can learn from that experience several times. So that's another advantage of experience replay. And of course, the final advantage is experience replay gives you an opportunity to learn from more experiences than if you were just learning from one at a time, because you have that batch, and therefore, and it's a rolling window, and therefore, even if your environment is limited to experience, your experience replay approach can help you learn faster. And instead of just redoing the environment many times, you can learn faster because you don't have to redo it. You have those experiences saved. So those are the main advantages of experience replay. Let's recap on them. We've got we're breaking the pattern of independence and correlation of sequential experiences. We save rare experiences which might be important, and therefore we can learn from them more often. And we can learn in environments. We can learn faster in environments which are experience, which have a shortage of experiences, or which don't have that many experiences that the agent goes through, and still we can be able to learn them. So that is what experience replay is all about. If you'd like to read a bit more, then there's an interesting article published by DeepMind in 2016. It's called Prioritized Experience Replay, and it talks about why are we using a uniform distribution to select our experiences from the experience batch? Why don't we find a better way to select our experiences and prioritize some of the experiences which we feel that are important? And so it's quite an interesting thing. So in this case, you will be able to not only reinforce your knowledge on experience replay, but you'll actually be able to move with the cutting edge of technology. So this is 2016 and published by DeepMind. So it's a very recent, very powerful paper. So you'll be able to actually explore the limits, or explore even further this algorithm and take it to the next level. So I'll leave it up to you to find out why and how we can change the uniform distribution to a different approach to experience replay from this paper if you'd like. And I hope you enjoyed today's tutorial, and now we know what experience replay is, and we can confidently use it in our practical tutorials. And I look forward to seeing you next time. Until then, enjoy AI.